Whenever I'm thinking of new project ideas, I keep being drawn back to procedural generation. There's just something so exciting about writing code that can be used to generate infinite possibilities. I thought it'd be fun to try to generate procedural castles, and to do so, I wanted to try to use the wave function collapse algorithm. It's a constraint-based algorithm, and it's most probably been used in the game Townscaper by Oscar Stallberg. A lot of procedural generation algorithms base their generation output on noise input, but wave function collapse is a bit different. You just have to give the algorithm an example of what you'd like to produce, so a 2D image or even a 3D scene, and then it will just use that input to figure out rules for how things should be arranged, and then it can generate infinite outputs that are variations on the inputs. So this is my 2-week journey of implementing a wave function collapse-based castle generator in Godot. I can't seem to get away from doing procedural generation projects, so I'm starting a new one. The overall idea for the project was that I would create a bunch of castle tile pieces, pass them into wave function collapse, and have the algorithm create cool looking castles. It seems like a lot of the examples of the wave function collapse algorithm in 3D might be overcomplicating things a little bit. My idea is that just like a 2D image, I can just place my 3D tiles in a scene and then use that to generate the constraints that are used by the wave function collapse algorithm to place them, but we'll see how that goes. The first thing I want to do is just make some really basic 3D tiles in Blender that I can use to make scenes. I'm a little nervous because I have barely done anything in Blender so far, so I don't really know what I'm doing. I modeled a really basic box room with just some corners, middle sections, and floor tiles. So I guess that kind of works to make a room. Then I decided to add in some little castle top pieces to make it look a bit more interesting. All right, so I guess this is a very basic castle. Just try to import these pieces into Godot and figure out how to arrange them. So tomorrow I can start working on the algorithm. I think I just need to import one version of every piece and then kind of rotate them in Godot. I made a new Godot project called Magical Castles. I exported my tiles from Blender and brought them into Godot. And I created a mesh library from the models and then started placing them on a grid map. I was having trouble here trying to get the tiles to align to the grid as I expected. They seem to be not aligning with the grid. And also, why are these floating? I eventually realized it was probably due to not having the origin tiles of each model set appropriately in Blender. So I went into Blender and moved the origins to consistent locations for each tile. But for some reason, I still couldn't get the tiles to correctly align to the grid map, and I wasn't sure what was going wrong. I'm not really sure what's going on here. I didn't have that much time to work on this today, but I think I'll just come back to this tomorrow and see what we can do. Okay, so it looks like my issue was just that I needed to uncheck the center Y box, and now pieces are positioning. Now we can build a little structure here. I made an example castle scene and then started thinking about how I could actually generate the constraint rules from that scene. I think I want to do the constraint generation before running the actual game. So to do that, I think I can use an editor script, which will just run in Godot itself. So what I'm thinking is that I need to look at this grid map and look at all of the tiles in it. And for every unique configuration of a tile, so every rotation of a tile, I need to get the constraints for the tile, which will be the tiles that are allowed to be next to it. So the ones that can be up, down, left, right, forward, back from that tile. Then we'll put it in some sort of data structure that I'll then save to a resource and then use in the generation algorithm. I wrote some code to pull from the example grid map, each use cell, the tile's name and the tile's rotation, and then use that to name each tile in the constraints research object. Then I wrote some code to go through each cell in the grid and check tiles in each direction from the tile in that cell, and then create a dictionary of constraints based on that information. Then I saved that data to a custom resource file. Okay, that seems like it works. So we have this resource file that has the adjacency rules, and then we can use that in the game. I started out this day by spending some time just improving my constraint generation code to make it a bit more structured. And then I actually got into the actual wave function collapse algorithm implementation. As far as I understand it, the algorithm is kind of like how you would solve a Sudoku puzzle. So in Sudoku, you have a 2D grid and you need to determine which numbers you can place in different cells in that grid based on the numbers that are already in the Sudoku map. And every time you pick a number to place, that constrains which numbers can go in different locations on the rest of the grid. So in my case, I have a 3D grid, and instead of numbers, I'm placing these tiles. I then wrote up my initial implementation of the algorithm, which took me a while and had some bugs. My general thought here is that we first select a cell that has not that many options, or in the beginning there's still a lot of options in every cell, so kind of just a random cell. Then we choose a random tile to collapse that cell to, so that it is the only possible option. And then from there, we have to propagate the constraints outward to adjacent cells, because the adjacent cells will likely be affected by the choice of the tile in that center cell. And then we have to keep doing that until all the cells in the grid are collapsed. However, the algorithm can sometimes hit a contradiction where there are no possible tiles that fit into a particular cell following the original input rules. And in that case, you can either do backtracking or you can just reset things entirely and start over. Initially, the algorithm was running infinitely and just never finishing. I have some infinite loops going on, which is not ideal. So I spent a while here just looking for bugs. I found and fixed some bugs. I think that might be the issue. But I was still having some issues, and I wasn't sure if my issues were because my constraints were wrong or because the algorithm wasn't working correctly. Seems like we're almost there. It's no longer infinitely looping, but I'm not sure it's succeeding either. So I decided to test it with a much simpler input map, just a single tile, and that seemed to be working. I mean, I think this is sort of working with this as the input. But I wasn't sure why it wasn't working with a bigger input example. We're getting closer, I think. There's probably just some small error here, but I think at this point it's getting kind of late, so I might as well come back tomorrow and try to figure it out with a fresh perspective. I started the day still not sure if the bug in my code was in the constraint generation or in the wave function collapse algorithm itself. It does seem like it's following the constraints correctly here. Like each block should just be only near air, and I guess that's working. But obviously something's going wrong here. I looked at the constraints and tried to manually see if they made sense, and it seemed like they did. I mean, this seems correct. So maybe the problem's in the wave function collapse algorithm, because it should definitely be able to generate something with these pieces. I found a bug which helped, but didn't seem to fix my issue. I think this could be the problem, or at least it's a problem. This is so close. I feel like I'm just missing something small. Eventually I discovered that if I switched to propagating the constraints using pop back instead of pop front, it would work, whereas pop front would run infinitely. Oh, wait. Oh, it's doing something. Was that the entire issue? It's making some castle-like structures, I suppose. I'm not totally sure why that's used to solve the problem, so I'm not very comfortable with that. I feel like there could be some other issue. I decided to move on for the time being just to get some other things implemented. On the edges here, I guess it's just building partial castles, which I should probably do something about. I think I can fix that though by just starting out by filling in the outer pieces with empty tiles, and that I think will fix it based on my constraints. This fixed things because it ensured that any tiles next to the edge of maps would be properly constrained to tiles that actually made sense next to empty tiles, so the tops of castles or the sides of walls, but not the middle tiles in the castle. Okay, that's kind of cool. So we have a bunch of different size castles forming, which I think is doing what I want it to. Kind of cool if I could see the algorithm in action to maybe understand better how it's working. I then decided it would be good to actually be able to visualize the algorithm in motion and not just see a loading screen. So I wrote some code to run it on a separate thread. This algorithm is quite slow, especially in GDScript, and not super optimized, but I realized there was a simple way I could optimize the initial generation. Yeah, at the beginning, it takes a while to show anything because it's first constraining the most constrained tiles, which are all empty because I'm setting the parameter to be empty. So if the empty constraints are the same every time, we don't need to calculate those every time. We just need to do them once. And the initial map constraining with the empty tiles around the borders could even happen offline before this program even starts, so that should speed it up a bit. So I wrote some code to store the initial propagated map data in a local variable to help with runtime between restarts of the algorithm. It's cool. We can see different generations now, and they're a lot faster because I'm saving the initial map with the initial constraints. I wrote some code to save the initial propagated map data to a resource file, so it would speed things up with the generation between reloads of the game. That's pretty cool. So now every generation starts pretty quickly, even for a big map, and even if I restart the whole thing, it will just start generating. Before I move on to improving this tile set to get some more interesting generation, I just want to make sure I fully understand why this line of code here broke my code when it was pop front versus pop back, because I'm not sure I totally understand what's going on here. It really seemed like it should work either way, so I was pretty confident that something was wrong with my code. I think it makes sense one should be faster than the other, but I don't think one should fail, so I think there could be some small bug. I spent a while investigating and just outlining how my algorithm was actually working, and I found and fixed a few bugs. I guess it makes sense that if I constrain cells in the order they were added with pop front, so removing the earliest added first, that this line here would make things break because we actually do need to update the same cell multiple times just from different starting cells to get things to work correctly. So I think this makes it run fine. Once I fixed those bugs, as I expected, both using pop front and pop back worked, and pop front was actually faster than pop back, so I switched to that. Seems like it's finally working, and I think I mostly understand what's going on now. Just for fun, I tested out a 50 by 50 by 50 map here, and it took 8 minutes to generate something, but it was pretty cool. Oh, okay. It finished. That's kind of cool. Not very practical. What I want to do now is make things look more interesting so that it's not just generating these really plain looking castles here. So I made a green block for grass, and I also fixed up the castle tiles a bit by adding a gray material. I brought these updated tiles into Godot and then figured out how to set up the ground grass to be the floor in the initial constraints so that all castles would build on top of that grass layer. I also had to modify the constraint generation code here to not allow empty tiles under the bottom plane, otherwise grass would just be floating in space. And then in the initial map data, I just set all cells in the grid where Y was 0 to grass, and that worked. Okay, that's kind of working, I think. Looking a little better at least. I noticed that it seemed like really tall castles were generating in more often than shorter ones, but I wasn't really entirely sure why. In general, it just felt hard to understand what was going on and how my input map was actually affecting the algorithm, so I decided it would be good if I could visualize that better. I started implementing an algorithm visualizer where you could actually see what was going on. Okay, I don't know how helpful this is, but basically now when I hit this button, it will start collapsing a tile, chose that one, and then it will propagate the constraints throughout the entire map, and you can see that process by the boxes moving around there. Turns green whenever it places a tile or when it collapses a tile. It does seem like it takes quite a while. Okay, so now it finished propagating, click continue. Now it's placing one there and propagating the constraints. I don't know, I think this will be helpful, but I don't think I'm quite done yet, but I also want to take a break and it's midnight, so I think that's enough for today. I wanted to finish up working on the algorithm visualizer. So I added a run to completion mode that you can click to actually just have the whole algorithm play out rather than having to keep clicking on the continue button. I also added a slider that lets you speed up or slow down the algorithm when it's running. I probably spent too much time working on this mode in general, but it did help me to understand things better, so it was probably worth it. See, when the map's bigger, it's like a ton of giant castles for the most part. I guess because it's like there, if you choose a high up corner, then you have to make it that tall. I thought I could probably implement some sort of probability-based system to lessen the frequency of this, but decided to leave it for now. You know, I think I might just start working on some better models now to make things look more interesting now that I have this debug mode. I had been putting this off for quite a while because I was nervous about Blender, but I decided it was finally time to try to make better castle tiles. I made some rounded pieces for spires, rounded corner tiles for spires to go on, spire tops with pointy tops and flags, and a more square-looking castle spire as well. I also had some basic colors and materials to these new tiles. They were definitely looking better than my old ones, even though they were pretty simple. It's kind of cute, I guess. One thing that I might try to do now is actually just apply some sort of brick texture or actually just brick normal map so it looks like there's bricks. I'm not sure exactly how to do that. To get this working, I had to UV unwrap my tiles, which I didn't really know how to do. I don't really understand what I'm supposed to do here. That is not really what I want. But eventually I got something sort of working. Some pieces still looked a bit weird though, and I wasn't sure why. I'm not sure why those are different colors. Maybe it's fine. It looks really weird though, doesn't it? I brought them into Godot and they looked even more weird. These look a little weird, but still probably better than before. This is not looking the best right now, but that's okay. We'll figure it out. I tried using wave function collapse with the new tile set, and it was looking a bit more interesting regardless. Okay, kind of cool. This lighting looks terrible though. Starting to feel a bit more fun. I ended up taking an accidental week-long break from the project, but I was back. This day though, I didn't have much time to work on it, only like an hour, so I decided to try to fix the visual appearance of the castle tiles. Clearly there's something going wrong here with the lighting. My guess is that there's something going wrong with the normals in Blender maybe, because I don't know why the bottom would be dark and the top would be lighter, and things just look pretty funky, so hopefully I can figure out what's going on here. So I went into Blender and turned on the mode where you can see the actual orientation of each face and that was indeed the problem. Okay, so some face orientation stuff is wrong here, I think. It ended up being very simple to fix just by recalculating the normals in Blender. I also spent some time here just editing the UVs in Blender to try to make the brick textures look a bit better. I brought these edited models back into Godot and things were looking much better. All right, that's looking better. I want to make this look a bit better as is, so let me try tweaking some lighting settings and see what we can do in the world environment. I enabled SDFGI in the lighting settings, which made things look a bit better. And then I also found a better looking skybox to use for the background and lighting, and I tweaked some settings around that. This was looking much better already. I tweaked the input maps so that the castles could have taller walls generated. I decided now to add something very essential to this project, a cute bird that would fly around the generated castle. So I tried to model a cute round bird. It's kind of cute, right? My thought is that can kind of just like animate as a blob. And then I tried to figure out how to actually animate it, but I was struggling with this and decided to take a break. I spent a while just trying to figure out how to rig and animate a squash and stretch animation for the bird. I eventually figured out how to make a very bouncy looking animation, and I brought the bird and its animation into Godot. I mean, it's pretty cute. I feel like this might be a little too squishy, but I guess we'll try it out and see. I started thinking about how to make the bird fly around the generated map. I added collision shapes to the castle tile set so the bird would collide with them. So my idea here is that once the map is finalized, I'll just go in and get a list of all cell positions of tiles that have air above them that aren't the ground, and then I can use that to allow the bird to fly to those tiles. So I wrote some code to get the global coordinates of any tile in the generated map that matches that criteria. Then I added a collision shape to the bird and wrote some code so that the bird would move to one of those tiles randomly when it's allowed to. I ran into some interesting bugs with bird movement. I initially made it so that birds would spawn whenever the castle restarts generating, so if you just regenerated the map a ton, you would have a ton of birds. The bird movement was kind of working, but a bit buggy. Oh no. I don't know why they're all going down and then popping back up. That's good. I made it so that birds fly into the sky when the castle regenerates so that they don't get stuck in the walls. It wasn't working perfectly, but the birds were definitely fun. I was also noticing some random crashes. Oh no, did it crash? Something weird is happening here. Probably not related to the birds. But I decided to come back and figure that out the next day. This day I wanted to improve the bird movement and fix the random crashes. The crash was related to accessing grid map functionality on the separate thread instead of the main thread, so I was able to fix that. Seems like now it's not crashing. I then made the birds rotate a random direction so they weren't always facing the exact same way. I should probably figure out why they are hovering and then jumping back up. I also made the birds snap to their destination when they were close to fix the birds just kind of constantly going up and down. I added some more grass ground tiles under the map to make things look a bit more chunky, but those tiles were actually not part of the algorithm, so that didn't add any time to constraint generation or anything like that. Make the birds fly around, maybe? So I think to get the bird moving around like I want it to, I should make it so that it flies up if it gets stuck.
A few moments later.
I just realized I forgot to hit record for the last like 40 minutes of work, but I fixed an error with the birds, and now I also have them moving around every 3 to 10 seconds, so give me a bunch of birds, and then they all come in, and then they'll just move around the environment every so often. I think it's looking kind of fun now. They might sometimes get stuck, but not very often, so this seems to work okay. I decided it was time to just work on some final polish for the game. I experimented with some different sound effects for when the castle successfully finishes generating and added one. So I have a couple of different things I was thinking of adding here. One, I was thinking when it restarts, you're gonna have like a puff of smoke indicating that's restarting. I was thinking when the parts kind of come in, there could be little particle effects that play back sometimes, kind of showing that it's under construction, but I'm not sure if that would be too much. Maybe we'll try it though. So I experimented with a bunch of different particle emitter settings, and then every time a new tile renders, I instantiated a new particle emitter and had it emit once. That's fun, but also too much. This was looking pretty cool, and I realized that there was a happy side effect of this. So it's supposed to be that the particles are emitting as it constructs, but when it goes away, it kind of looks like it's exploding. Kind of unintentional, that looks like it's a poop of smoke when it restarts, but I like that. Adds some visual intrigue, I think. Then I decided to add a success particle effect when the castle successfully finishes generating, like a sparkle or something. So again, I messed around with a particle emitter and some different particles until I got something I liked, and I added that to the game. All right, that's pretty pretty fun. Maybe I should make the ground more interesting somehow. That might help. So I found a grass sprite and set up some plane meshes to render it. I looked up some shader code to get the grass to sway over time. And then I wrote some code to actually spawn the grass in around the map. It probably looked better if it was like covering things more randomly. I eventually decided to place the grass at every grid cell location on the bottom plane of the map, but I randomized the offset a bit from the center of each cell, and I also randomized the size of the grass to give it some variation. This was looking decent, but I had some weird visual glitches. They also have like something hovering on top of them, which isn't the best, and I didn't know what was going on. I decided to try modeling the grass in Blender instead to have more control over the model and just make it one piece instead of multiple combined pieces, just to see if that would help anything. Okay, that does look better, I think. So I changed the grass to be a bit more the same color as the rest of the grass block. I think that looks a bit better, but there's still some weird things going on here. There's some weird visual effects, like lines on the edges of the grass textures, and I'm not sure what's going on here exactly. It doesn't look ideal. I did some research and discovered that the barely visible lines on the top of the grass was an issue with mip maps and texture repeating. Looks like it's mip maps. And I was able to fix this by just turning off texture repeating in the shader. Okay, disabling texture repeating fixes that as well. I was pretty happy with how this was looking now. Then I added in a swoosh sound effect that plays whenever the algorithm fails and needs to restart. So it's been over 2 weeks since I last worked on this project, which is kind of silly because it's basically done, but I took a break to work on a game jam and make the video for that. So I'm just coming back now, and this is the last day I want to spend on this project. There's a lot more I could do, but I think it's looking pretty fun as it is, and I kind of want to move on, but I want to add a little bit more polish to it. My main problem is that this just looks like it's in a skybox because it is. So I'd like to add some sort of ground plane, like maybe water or clouds underneath this island. So I added a plane underneath the ground plane and started messing around with some water shaders. Eventually I would like to learn about implementing my own water shader, but for this project I decided to keep it simple and just experimented with some different ones from Godot shaders. There were some nice looking ones, but eventually I found one by Molito and it's awesome. Definitely go check that out. I'll have it linked in the description. I then added another light to the scene to make things look a bit better, and I tried to position it generally in the same direction as the skybox sun, and I think it looks pretty good. Yeah, I think it looks better with the light there. It doesn't really probably make entire sense because the skybox has the sun up here and then there's light here, but I like how it looks. Maybe we need some chill music too. Then I added some chill piano music for the background music. Then I added some basic tutorial text. Then I decided I was done. All right, so I think with that, I'm pretty much done with this project. But then I actually decided I wasn't done. All right, so I know I said I was done earlier today, but I think I do want to make it so that we don't have these really giant spires on their own because I feel like it doesn't look that great. So I'm thinking about how to do that. I think basically the reason why that happens is because when a tile is chosen at the top of the map, it may be one of these top tiles for these spires. And then if that's chosen, that means it has to build all the way down a spire. So you end up with these really massive spires, and that's not ideal. I wasn't sure what the best way to fix this was, so I tried a couple different ideas. I first decided to try using noise to set a max height for each XZ coordinate on the grid, where anything above that height would need to be empty. So this area has nothing because the noise values make so that it has no height over here every time. This is kind of interesting, combining noise with wave function collapse, but I don't think it's what I want because yeah, you have the same thing every time where this is empty and this is high. I could make it so that the noise changes every time you redo the map, but then I'd have to propagate all the initial constraints again based on the empty tiles, and that was something I optimized to avoid doing. So I think this approach doesn't really make sense right now, but it's kind of interesting. So I saved that code on a separate branch and tried a different approach. Maybe we make it so only 10% of the time you actually keep the really tall towers. I decided to keep it simple and just add in some code in the collapse method that if the algorithm chooses a square spire top piece above a certain height in the map, it would have a 90% chance of choosing another tile instead where possible, and that helped a lot. I think this is better. It's not perfect, but it's better. I think this is fine for this version of it. I think there are definitely better ways you could address this, but this was good enough for now. Then I decided I had one more important thing to add. Should I make the birds tweet when you click on them? Maybe. I keep saying I'm done though. I wanted the birds to tweet and fly away if you clicked on them. So I added some code that would make the birds fly to a new location upon click. So you make the birds fly away when you click on them. That's fun. A little more interactivity. And then I spent forever trying to find a bird tweet sound and eventually got one I liked. All right, that's good. Then I decided for real, I was done. All right, now for real, I think I'm going to call it for this project. I think it turned out pretty well. I like how it looks. I like the vibe. And also, I like the birds. Definitely adds some more charm to it. Yeah, I think this turned out pretty well. There is a lot more I wanted to do, but I think I'm happy with where it is for now. This is a really fun project. So this is the final project. I'm really happy with how it looks and the different interesting castle patterns it can generate. I think my favorite thing about this project might be the particle effects. I feel like they make things feel so satisfying, especially when the algorithm has to restart. I actually don't mind because it's just fun to watch. If you'd like to try it out for yourself, I'll have the project linked on itch.io in the description. I think it would be fun to add more castle tiles to this to give it some more variation. And I also do think it would be really fun to try to make something more like Townscaper, where you can click to place blocks in the algorithm, and I'd like to do that eventually, but I'm happy with this for now. If you'd like to take a look at the source code for this project, I actually just started a Patreon page for anyone who'd like to support the channel, where I'll be uploading the source code and assets for my YouTube projects going forward. I've also uploaded the source code for my previous projects, including the Minecraft game and the procedural snake game. So I'll have that linked in the description as well if you'd like to check it out. Thank you in advance for any support over there, but I also just want to say I really appreciate all of you here, all of your nice comments. It's been great getting to start growing this community, and I'm excited to see where it goes. Thank you all so much for watching, and I'll see you in the next video.